To demonstrate the case sensitivity of the C language, let's introduce a couple of errors. I'll first change the case of my num1 to capital N down here in the CN statement, but I will leave it as num1 in my declaration statement when I define the variable num1. I spelled it the same, but I've used a different case. Let's recompile this program and see what happens. As you can see, it has given me a message that says one error. If down in the output window I scroll up to where the message is, it will say num1 undeclared identifier. Of course, since we just introduced this error, we know what the problem is. But in reality, we may not know this. So if you simply double-click on this error message, it will then take you to the occurrence of this error. And it tells you that it does not recognize num1. Of course, the simple solution here is to change this back to lowercase n. And then we'll recompile the program, and it compiles without error. Let's discover the importance of this compiler directive include IOString. I will do so by making it a comment. By doing that, you'll notice that it has turned green, indicating that it is indeed a comment. But more importantly, it is now considered non-executable code, which means that when this program is recompiled, this statement as if it will be ignored, as if it's not there. Let's see what impact that program or this introduction of this error will have on this program. I'll compile it, and I get 10 errors, and all I did was make that a comment. Let's scroll up to the top of this, and you can see that it gives me a message that says cout undeclared identifier. And all these messages have to do with the cout and cn statement. In this program, since I have taken away the compiler directive for the iostream.h, it does not recognize anything associated with the cout or cn statements. So don't be alarmed when you get messages that indicate that there are multiple errors. It might literally be just one mistake. In this case, that's exactly what it is, as I recompile this program after correcting it, and of course it is now error-free once more. Now I'll introduce an error with our summation statement, that is where it says total equals num1 plus num2. I will also make this a comment by placing the 2 forward slashes in front of it. Now, I've got the variable total declared, and I am displaying the result of total here. But if I make this a comment, then C will not know what the total of num1 and num2 are. Let's recompile this program. I'll click on Build, because I know it's going to compile. It knows it does give me one warning. Let's take a look at what that warning says. It says local variable used without having been initialized. What this is telling me is that I did not give total an initial value. Well, let's just see what happens when I run this. This is a warning, which means I can run this program. So if I type in some data, such as 5 and 8, I get a result of a very large number, a negative number in fact. And what this is the default number that's being associated with the variable total in memory. This obviously is not our correct answer. So that warning was trying to tell us that we're referencing a variable called total, but we did not give it a value at any place in the program. We could have given an initial value of 0 up here that says equals 0.0. And let's see what effect that will have. I'll rebuild the program. Notice I'm now back at 0 errors, 0 warnings. I'll use the shortcut button to execute. Click on 5 and 8 again. And now I get the sum of the numbers equal to 0. Remember, I still have my summation statement commented out. But now I do not have a warning because I have given total an initial value of 0, and it remains that for the duration of the program. It's a good idea to always initialize your variables, and we'll talk much more about this in the next chapter. I'll make one last change, that is putting the total statement back as it was, rebuild this one more time, just to verify that it does indeed work. 5 and 7, of course, is 12.